Hey everybody, Tim Chambers here. I am your professor for MSE254 this semester, and I'm just doing a little self-introduction video to say, hi, welcome to the class. Happy to have you here, and I'm looking forward to teaching you. So this is my third time teaching this course. It started out as sort of a pilot trial elective thing. Hey, maybe this is a good idea. Let's see what happens. And it went okay. And so I taught it last year as a full enrollment class. And then this year, it's now a required material science course, which is great. We really want our students to have strong understanding of and ability to use mathematical tools in material science and engineering. So that's what this course is about. It's not really at all about just knowing the theory of math for the sake of the theory of math. Like, I'm a math nerd, sure, I think it's neat. I like being able to prove stuff, but that's not what this class is about. This class is about how do you use the math that you've learned and the advanced math that we're going to teach you in this course. We're going to do partial differential equations, Fourier transforms, complex analysis, linear algebra, eigenvalue problems, like all this good stuff. We're going to add that into your toolkit so that you can solve interesting materials problems. And so in all the assignments for this class, you're going to see some pure math practice problems. Hey, take this integral or do this derivative or plot this function. Like, yeah, you got to practice those basics. But then we want you to say, okay, now let's use this for an actual application. If we're doing rotation matrices, let's talk about symmetries in crystal structures and actually understand, like, how do the positions of atoms in a lattice relate to each other? Or when we're solving eigenvalues, let's solve for the energy levels of electrons in a semiconductor. Or when we're doing, I can think of so many examples, when we're doing Fourier transforms, let's talk about reciprocal space. How does X-ray diffraction work? Like, how do we measure the relative positions of atoms in solids? How do these tools work and what's the math underneath them? So throughout the semester, we'll be doing these kinds of applications to really help you see how the math is useful and get you the ability to apply that math. Now, in order to do that, there's two toolkits that you need. One is the conceptual understanding. You have to understand the ideas. How does this stuff work? What are the numerical and quantitative relationships involved? How does one do these calculations? But then there's also the practical implementation of it. And I don't know if you've noticed, it's the year 2026. Not a lot of people just calculating orbital trajectories with slide rules anymore. Yeah, that was cool in the 50s and 60s, but that's not the modern engineering world. We solve problems on computers. And so this course is about half and half. It's about 50% doing old-fashioned math by hand, learning the basics, practicing those numeracy skills, and then half getting into numerical methods. How do we apply these things on computers, and how do we use computers to solve math problems that are literally impossible to do by hand? So we really want you to have a balanced experience with getting the best of both of those worlds. And that's kind of where we're going with this. So that's the course in a nutshell. I'll talk a little bit about myself in class, so we'll do the sort of personal introduction stuff there. But I just wanted to give you a little sense of what the course is about and what some of the goals are and why we're doing all this. Now, as far as the course structure, how does it work? This is all in the syllabus, but people like videos, so, here it is. The details are in the syllabus. Yes, you should go read it. Yes, it's good for you. Eat your vegetables, yada, yada. But basically, this is a flipped class. So your lectures will be videos like this one, maybe a little more stuffy and formal, probably some slides and animations and stuff. But you'll watch those video lectures outside of class and then complete your check-ins about those lectures. And those are really one of the most important parts of the class. I know it can seem like sort of a time waster, busy work accountability check. And yeah, of course, there's an accountability measure in there. It keeps you watching the lectures and it keeps you, you know, accountable for being able to report on, yes, I did the homework ahead of time like a good student, like I'm supposed to. But that's not really the main point. The main point is it gives us an avenue to communicate one-on-one. I'm the teacher, you're the student. You have questions, you have thoughts, you have ideas, confusion, inspiration. All this is part of what you bring to the class, and I want to learn about that. There's 60 plus students enrolled. I'm not going to have time to have deep conversations with everyone during class time. If you come to office hours, which you absolutely should, then I love having those conversations in office hours. But, not everyone's going to be able to make it all the time. And so what do we do? How do we interact? Well, this is what the check-ins really give us the opportunity to do. It lets you submit questions that you want to ask directly to me, and then I can answer them directly to you. Now, if there are questions that lots of students ask, I give you a lecture video on some topic and everyone's like, this doesn't make sense. What am I doing here? I'll address that in class with the whole group. I don't want to be inefficient with people's time either. But sometimes you have something you're curious about or something that interests you, or sometimes you wonder, hey, I learned about this other stuff in this other class. Is that kind of like this thing that we're doing now? I love doing that engagement. So give me those questions in your check-ins and I will respond to them. And that lets me have some one-on-one dialogue with every single one of you every week. And to me, that's a great strength of the class and one of the parts I enjoy most about doing the teaching. So really give those check-ins some love and do them yourself, do them thoughtfully. I recommend taking notes as you go on the lecture videos. So really just kind of write the check-in as you're doing the lectures. It's not a formal thing. It's not an essay. It's certainly not a formal report. It's more like a journal entry, if that makes sense. So don't worry about sounding fancy. Certainly don't worry about sounding like you know what you're doing. You're learning stuff for the first time. You shouldn't know what you're doing yet. But instead, think of it as a way to communicate to yourself about how you're thinking and how you're understanding, and a way to share that communication with me so that I can help you advance further. All right, I don't want this video to go on longer than the lectures it's supposed to introduce, so I think we'll call it there. But if you have any questions, shoot me an email anytime. I'm more than happy to help you out. And with that, get going on those first lecture videos, and I will see you in class.